Hello, in this video we're going to look at how SLOs are used to help you get to the bottom of issues in your application using Honeycomb and our unique bubble up feature. Now SLO stands for Service Level Objectives. They're a way of defining a threshold of what is good and what is bad within a specific context of your application. Now this could be based on logs, spans, or even just raw event data. But with SLOs, we can define different levels of alerting based on how quickly we're going to breach that objective that was set. Now let's look at an example of where we sent a Slack alert to someone to let them know our checkout response times will breach that SLO in the next 24 hours. Now if this does happen, we don't necessarily need to be paging people in an urgent way, getting people out of bed. But we do want them to pick it up as soon as possible. So they'll get a Slack message a little bit like this. Now let's click through that Slack message and see what's happening on our SLO page. So we can see that we've got an issue that we're going to be breaching our SLO in the next 4 hours. That's not good. But the question is why? So let's scroll down and see whether there are any correlations, anything that ties those bad requests together. Now we use something called bubble up here. Now this is going to take all of the attributes from the good events and all the attributes from the bad events and match them together to see whether there's anything that ties them together. Now if we click through here, we're looking at this and saying, well, everything is the same. It's an even distribution. So it looks like there's nothing identifying which ones are the problem areas. So let's scroll up and have a look and see if we can look through any more data. Now we've got something called a heat map here. Let's click through and see where we get to. Now this is a heat map. A heat map is a three-dimensional graph. It's going to have our duration up the left-hand side, time across the bottom, so like a standard graph, but it also has a third dimension, which is density. So the darker colors mean more events landed in that particular segment. So we can see clusters, we can see patterns. Now we can see on this particular one here that we've got a big stretch of these slow ones at the top here. So let's click on a couple of these and see what we can see. This takes us into something called a trace waterfall. A trace waterfall is going to show us the distribution of durations over that entire request, from the top all the way down to where it hit databases, that kind of thing. So we can see here that the majority of our time is taken up by something in the cart service. Now we could make some guesses, but it'd be better to try a couple more and just see whether that's common to all of these. Now that one's the same, something in the cart service. Let's just do one more just to make sure. Yep, again the cart service. Now if we click on an individual span, in the top right hand corner you can see that we've got another heat map. Now if we click through on that, we're going to be able to go into another query, another heat map, and this time I'm going to use bubble up. Now bubble up can be used from our SLOs, but it can also be used from any one of our charts. What that allows me to do is draw a box and say these particular events, or spans in this case, are interesting. Tell me about them. Now what that's going to do is it's going to do the same as it did on our SLO board. It's going to take each of those individual spans and all of their attributes and compare their attributes to the ones that are not interesting, the normal ones. And now we get a more interesting view. Now we can see in this top left-hand graph here that the majority of these yellow box spans have an attribute called app.cart.unique items. And the value of that is quite high, 7, 8, 9, 10. So it sounds like actually this is potentially a problem with only those particular baskets with a lot of unique items. Now we can verify this. If we go back a few queries back to our checkout view, we can use another query and say, if any of our requests have only 7 or less items, or less than 7 items, what does our graph look like then? Now, as we can see, that top bar is completely gone. What this shows us is that although the problem is showing up in our checkout process, and that's what customers are seeing, which is why we've got an SLO about the customer experience for checkout, the problem is actually to do with our cart service. And we've got some actionable information around the idea that this is a problem with large amounts of items in the basket. As you can see, an SLO is really just a starting point for an investigation. It allows us to have an early warning system so we can have some deep investigation around that causality of what fails in our systems and why, what makes them slow. And we do that by focusing on the user experience rather than how our individual microservices are performing at any given point.